She's making a few bucks off of you.
That's really funny. So, Brody, if you're listening, we're agreeing that we're all quite jealous that you're in Florida and we're stuck here. Okay, so let's take one pass more. So today we're going to take a little note and kind of formalize what we talked about yesterday in a big group setting, and then I've got a little assignment that will get started, which isn't going to be due for a couple of days anyway, not till we get back on the Monday, but you guys will have a one-day head start. So we're not actually going to be doing much math yet today. We're going to be doing a lot of kind of defining terms and just making sure we know how to work with triangles. But this whole unit is about trigonometry.
So pretty much.
Triangles, just like we did last unit.
Say what unit 3 was.
Yeah. So unit 2 was also a type of trigonometry, similar triangles. This one is what we call right angle trigonometry.
Oh yeah, you were saying you were split up into 2.
Yeah. So this is all right angles. We're dealing all with triangles that have a 90-degree angle. So I want to talk about the degree. And didn't I find nice pictures? I was quite pleased with myself. I made this note. But so far in our math lives, we've measured angles in degrees, right? And so I've just put a couple pictures here to show you what a degree is, a single degree. So out of a whole circle, it's just that little sliver right there. Yeah, that's 1 degree. And on a protractor, it's just that little sliver, the first tick, 1 degree. Right? You can see it right there. So it's not very big. And just like we talked about yesterday, how did we come up with the degree? What is that number? What's that mean?
I don't remember you said my answer was wrong.
No, I didn't say your answer was wrong. We kind of built on it. But if you look, I mean, why have I drawn a whole circle? Because how do we... Good, that's right. So we decided as a culture, collectively, one day to take a circle and just cut it into pieces. And how many pieces? 360, which is kind of a random seeming number, right? But we took a circle and we just said, let's slice this thing up into even slices, and we're going to cut it into 360 slices, which is kind of a weird number.
And now, to this day, we're also familiar with 160, 720, 520.
And it's funny how these things stick around. I was thinking, you guys learned last year about y equals mx plus b, the equation of a line. That sound familiar?
Nope.
That's okay. No. We'll talk about lots this year. But those letters, like we have these equations and we use letters. And
I actually that's one of the things we didn't even get.
That's okay. We're going to do it to death this year, so don't worry. You're going to have lots of practice. But these letters, like M stands for slope and B stands for y-intercept. And you think, why those letters? And yeah, so a class asked me, and that's okay, we're going to talk a lot about what this means, but the class asked me, like, well, why do they use M for slope? And I thought, I don't know. So I went and looked. Nobody knows. Like, some people have some theories, some people have some ideas. None of them sound terribly credible.
So in other words, it's
the answer is sometime in the past, somebody said, yeah, we'll use this. I mean, I don't know. Maybe those were his initials. Maybe it was like Matthew Broderick. Maybe Matthew Broderick. I don't know. But you know what I mean? We have no idea why. We don't always know. And if you were designing a brand new system, maybe you wouldn't do these things. But we're not, right? We're working with. So if we were starting and building math from scratch today, would we have picked 360 as the number to cut a circle into? Probably not. There's probably better numbers than that, right? But it doesn't matter because that's what we've always done, and it works. It does work, right? I mean, if I tell somebody to build something at a 45-degree angle, they can picture in their head what that looks like, and they can grab the protractor and they can do it. The system works, right? Does that make sense?
The only reason why I think people don't have a reason to do it, like don't have a problem doing it, is because we've been doing it the same way for so long.
Yeah. So what we talked about yesterday and what we're going to dig into this whole unit is that we can measure angles a different way. All right? We know that the angles in a right angle triangle depend on how long each side is. That's what we kind of started to look at yesterday. So I'm just going to draw a little picture of that, and you guys can kind of do the same. But if I take a triangle here, and I measure this angle, yeah, just, it doesn't matter. Just draw a triangle. if I extend this side, if I make this side longer, what happens to the angle? I should have put that label outside. If it's not too late, you should do the same. Yeah, if you put it on the inside, that's okay. But that was stupid of me. If I make that longer, the angle gets bigger. Does that make sense? Well, that's pretty straightforward stuff, right? If you want to make a bigger angle, I've got to make that far side bigger. Now, I don't want to blow your mind here, but what if I started with a triangle and I wanted to make that angle smaller? What could I do?
You would just make the one side shorter.
Yeah, if I make this side shorter, now the angle gets smaller. That is some of the worst drawing anyone has ever done on a smartboard right there. That is just as bad as it gets. That's okay. I'm gonna like.
Yeah, I was gonna say I'm already starting to remember here.
Well, that's all we're writing on this page, so you're good. Yeah, I have an ability you don't to take my writing and move it.
Yeah.
That's something you don't get to do. But there we go.
I mean, we don't do it yet. I mean, 10, 15 years now. That's probably.
I have, for the past 3 years, I keep putting in for grants to get a class set of these, so everyone could have one. And they keep turning me down. But one of these years, I'm going to get that because I think that'd be amazing.
Even if you didn't get like the Microsoft ones, you got like the Leno's.
Yeah, no, for sure. Like just something that you can write with. I'd love it because it's changed my teaching life. I love it so much. And you think like you guys could automatically have my notes, and you could draw all over them. I could do so much with it. So one of these years, or if like one of you has like $30,000 kicking around, you want to lend me, that'd be great. Like I would totally write you such a nice thank you note. I'd like put like a smiley face and a sticker on it. Maybe one of the stickers I have with my face on it. Like the whole thing. So does that make sense? I mean, this is really straightforward stuff, right? If we make that long side bigger, the angle has to get bigger. If we make that long side smaller, the angle has to get smaller. It's fair, right? Okay, flip the page. Let's take a look at the next side. So I'm going to introduce you to a few new terms. New terms. Okay. When we look at an angle, when we have an unknown side, what letter did we usually use to talk about it? Yeah, we could use other letters, but most times we used an X, right? When we have an angle we don't know, like this one, we use this symbol. Everyone see that? That little symbol there. Yeah, and it looks like this. And it's called theta. It's a Greek letter. And for whatever reason, this is another one of those things. Why do we use theta to mean an unknown angle? Couldn't tell you. The answer is theta. Say it back to me.
Theta. I thought you said
Theta.
theta. I'm like, wait, what?
Not theta, theta.
Wait a second.
Not feta cheese, though that would be good. Theta, and we use this used for an angle we don't know. So the Greek letter theta is the letter we choose to use for angles we don't know. I don't know why. I don't know why they don't just use X. But the answer is, just like we're used to using X to solve a side we don't know, they wanted us to have something that when we see it, we'd think, oh, I'm supposed to find an angle. Does that make sense? So if you look at all these pictures here, what angle am I trying to find out about in this triangle? Yeah, top left, theta. The unknown angle theta, right up here in the top left. What is the angle of interest in this triangle? The bottom one. Does that make sense? So they show you what angle you want to know about by putting the theta there, by telling you that's the angle we want to find out about. Does that kind of make sense? Okay. Now, that's important because remember we said, go back up here, flip to the last page. If I wanted to know about this angle, the one example we showed here is I can control that angle by controlling the side across from it. Does everyone see that? So, and I could control this angle by controlling the side across from it. So which angle we're talking about matters. Does that make sense? Because if I was talking about this angle, is this the side across from it now? Now it's the side next to it. Does that make sense? So when we label our triangles for this one, remember with similar triangles, we'd always just label them A, B, B, C. That's how we'd label our sides. When we do right angle trig, we're going to label them a little differently because we're always going to label our triangles in relation to the angle we want to find. So the angle across from that, I'm going to call the angle across from that. What's a word that means across from something? If somebody's on the other side of the street, they're on the far side. What's another word? Oh, word.
Opposite.
Very good. So we call this side the opposite side. So the side across from the angle that we're looking at is called the opposite side. And I won't usually write all of opposite. That's why I ran out of room. Usually I'll just put OPP because I'm lazy. But that stands for opposite. Now, you know what the big long side is called. What do we call the longest side in a right angle triangle? Very good.
I swear, I got that wrong in my test.
We call this side the hypotenuse because it's across from the 90. I'm going to put a couple of little notes in here. I'm going to remind us that this is across from theta and that this one is across from the 90. Did I spell across right? Is it 2 C's, 2 S's?
No. No, 1 C 2 S.
Yeah, 1 C 2 S.
Is it?
Yeah.
Okay.
Sounds looks right.
That looks weird to me too. They both look wrong to me. It's causing me stress. I'm going to leave one of each, and that way, no matter what, I got one. On the other hand, that way, no matter what, I'm wrong on one. But
Yeah, but at least you're right.
I used to have a kid who, you know, how sometimes they do like the matching questions on a test.
Oh, I hate those.
I hate those too.
There's so
Like, can I show you what I mean? Like,
when you put like where
uh,
you just place the letters. I hate the ones where you actually have to draw like all the lines.
so where would
But I think I know what you're talking about.
so like here we go. So like here's a test I gave where like
What is that?
it's a grade 11 university math where they have to match like the different graphs to the equations of those graphs. It's not nearly as hard as it looks. But I had a kid who would always just go A, and he'd be like, well, I got one S7. And then he'd go put the mark up here for me. And I always thought that was fun. I thought like, oh, that guy. Anyway,
That bugs me.
what, that he would do that? I'll let him know. I'll say, Scott, hi.
Hello, nice to meet you.
Ah, bonjour. Okay. Now, yeah, so we'll get you caught up, but right now we're on the second topic. Oh, yeah, so right now, no, it's on top, but just flip to the second page.
All right, sounds good.
So we're talking about our new unit where we're studying right angle triangles. And we said we introduced a new language. First, we said that this symbol here, yeah, that's not the script. We'll test that in this moment. So we said when we have an angle we don't know, we put this little letter theta. And there's a theta. And that is a Greek letter. It's just no different than X or Y or Z or T. I'm not saying you should, whatever you name your kids, have the first letter of the name be theta, but it'd be different. It makes a th sound just like RTH, right? You could name your kid like Benita, and you could start with the theta. And you'd probably, and like, it'd be fun to watch like when he had a supply teacher, watching the supply teacher try to pronounce it when it has a Greek letter in it. I think that'd be entertaining. So up to you, but if you wanted to name your firstborn child Thanita, Joseph, whatever your last name is, that's cool. I support that. Anyway,
I think C would be a cool middle name.
so we show the angle we're interested in with a theta. And it could be either of the unknown angles. By the way, this triangle only has two unknown angles because we know one of them. What angle do we know? Yeah, the 90. We know the 90. So we're never going to put a theta here because we're never going to be interested in the 90 because we already know it. Does that make sense? You know, I'm never going to ask you what is this angle because boring question.
It's not 90 degrees.
So now we said when we do this kind of question, and today we're not going to do much math with these. We're just going to work on labeling them and then finding the most basic facts about them. We're going to talk about that. We call this side theta. We call the side across from theta the opposite side. We call the side across from the 90 hypotenuse, and we knew that. We've known that for a long time, right? And then we have this other side, and it uses a really antique word. What do I mean by an antique word? Yeah, you know, like for example, if I said, Cassie, how was thine meeting today? Didst thou have a good time? It would sound a little awkward, right? That's a little weird. Yeah, because we don't speak that way anymore. That's old language. This is an old word too. So this side is across from theta. We call it the opposite side because opposite's another word for across. This side is touching. It's next to theta. And so the word for something that's next to it and touching it is, and again, this is an old word. It's not a word we use often anymore. It's the adjacent side. Adjacent.
That sounds so much like adjustment.
Yeah, it's a strange word. It is an English word. I swear to God, it really is. But it means it's the side that's next to theta. It's the side that's touching it. Having said that, let me tell you how I do it. Even now, when I teach this crap for a living. When I
like right now, I'm looking at it and I want to change it to adjustment.
Yeah, that's okay. Because when I label the sides, I start at theta and go across from that. I call that my opposite. I look at the 90. I go across from that. I call that the hypotenuse. And then the side that's left, I call that the adjacent. Does that make sense? Just worry about the other two, and the side that's left, that's the adjacent.
Is there like an abbreviation we can put for that?
Yeah, I was just going to talk about that. We normally aren't going to write these big long words.
Oh, never mind.
In fact, usually we will just write either one letter. For today, I'm going to have you write the first three letters: OPP, HYP, and ADJ. Does that make sense? So let's take a look. Why don't you try these two? I want you to look at theta, make sure you know where the 90 is, draw the little 90-degree symbol in there so you know which side's your right angle, and I want you to try to label the sides relative to the angle I'm interested in for these two triangles here. All right, I'll come around, I'll walk around and say, hey, good job, or, oh, you're getting it, you're close. What should we do? Oh, let's switch that one, right? And then you'll be like, oh, I know what to do, and we'll switch another one. No, he came in late, it's all good, I'll help you out.
How do you say you spell the opposite, like in short form?
Just OPP is fine.
Okay.
Yeah, first three letters of each one is great. Okay, so the first thing we do is, so on this triangle, where's the 90?
No. Honestly, that I just do this.
Yeah, of course.
This
That's that. You see that side? Yeah, you're exact. Like you're right that that's a 90.
Oh.
But one corner is always going to be a perfect corner.
Oh,
Right, this is the corner of this root. Does that make sense? Where's the 90 on this one? You got it. Good. So now, to name the sides, on this triangle, I showed the angle I'm interested in, which is moving equal to theta. So on this triangle, what angle am I interested in? Yeah, so there's three angles, the 90 and then two other ones. And I show the one of interest by putting a little green letter down. So what angle am I interested in this time? Not your question. I'll start from the theta. That makes sense? I'm interested in this point. Oh, okay. So when you get to questions where you're actually finding the angle, that's the one that you get into the math to figure it out. Okay. And we made a triangle from these two sides. The one across from the theta, you call that the opposite. You go across from theta, right? So it's neither of the sides touching theta. So right here on the opposite. Nope. From theta, you go across the triangle. Oh. So that's the opposite. And you just put OPP. Okay. Now we did the same thing with the 90, and across from the 90, what do you call that side? We call that hypotenuse. Right. Yeah. So HYP. And then the adjacent is the one that's touching that, that's just the leftover one. The way I always do it is I find the opposite, I find the adjacent.
Adjacent plot.
Yes, find the opposite, then I find the hypotenuse, then the leftover side.
Why so
right here, you go right on the angle. That's right, and that is the opposite. Yeah, that's right. Oh, okay, that's it.
Wait, no, definitely a second.
Okay, well, give me a second. Ah, yeah, erase them. Okay, but yeah, you're right. And that is perfect. Good.
I was gonna say Wade. I love it.
Okay, love it. So across from theta is the opposite. Across from 90 is the hypotenuse. That's what we said a few days. Yeah, what am I going to yell at you about? I'm going to get real angry like this. Knock the chair over and walk in and be like, oh.
We just put H for hypotenuse instead of like.
So now I want you to do three letters. Eventually we'll get to just one, but for now I want, because I want you to not, here's what always happens. People go, that's the O, that's the A, and that's the H. It's like, okay, that's fine, but I want to make sure we know those things.
No, I was doing the three letters for the rest of them. I just wanted to do hypotenuse H.
Yeah, okay. Okay, so how do we find the, how do we find the opposite again? Where do we start? That's where I messed up. Because I forgot that it's X. So I started with theta and go across. Right? So they got it.
I mean, go across that X. Like, I got to look at that.
It's always just left of it.
Nice, I know, man.
What it means, it means the side that's touching theta that isn't the hypotenuse, it's kind of a weird definition, right? So instead I always say the opposite side, and then the hypotenuse side is shot, and left over is okay, now, this side is the
We
90.
put the right answer, it didn't expand.
No, did not.
We need to go in depth.
So, there's the hypotenuse.
Did you ever get this?
I'm gonna look
So
at
that's the
that.
whole side, right? That's the whole side.
Oh, I'm gonna do that.
That's okay. So the hypotenuse. And remember, it's the whole side. By the way, you wrote opposite here, but is it this side or this side?
I'm having trouble reading your comment.
Oh, that's because I'm messy.
Well, 'cause it looked like you scribbled it out, but I don't know if you like.
Good, very good. Now do the same thing.
How do you get that on your?
And remember, it's side
Yeah.
and I like Yeah. Good job. Well done. What I'm trying to show you is that you have this set up well.
Yeah.
So the scale factor is right here. 12.6 divided by 2.3. But
Seriously?
Yeah, but which you did right, like in all the other ones, and here you just outsmarted yourself. You did 2.3 divided by 1.7. Or no, you did. But
I didn't do
maybe.
Well, 'cause then
Oh, sorry, I said, so there's supposed to be a not there. Those are. I don't know what it is. So that's it. So the scale factor. Oh, then I see what you did. You multiplied the scale factor by this number.
yeah, I don't.
Not by that number. Okay. So
No, I'll tell you why.
Yeah, no, that's fine. So I know
When I did it by this, I got some really small numbers. I thought it was wrong.
you got some other stuff. Yeah, it wasn't a big deal. It was like a shed. Maybe tall. But it wasn't some monster thing. It was tall enough. But yeah, that's
that would have made so much more sense.
It's a small one.
No, Friday.
Like I will backtrack with you. Okay, we're gonna forge ahead. So So, oh, I hate when that happens.
Really? Goes to the point where if I have to draw like a diagram or something in science or anything, I get made fun of for it.
Okay, so in this case, what side do we go for first? Oh.
Oh, that's a cute picture.
Oh, look at us.
Where is that?
Francisco. That's the San Francisco Bay Bridge, and we had just biked across it and come back. And I looked smiley, but mostly I just felt like I wanted to die. Because it was like it was a great day, but I was in better shape then. We biked all the way. It was really cool. From San Francisco across the bridge down to a place called Muir Woods. Why is OneNote not opening? Just play nicely, honest to God. To a place called Muir Woods that has a bunch of redwood forests. And when you go there, they have this amazing redwood tree that is so big around. Yes, but they have one that has fallen over and they've cut it off. It's so big around, they've got the rings named on it. And you know how you can tell how old a tree is by how many rings it has? Well, they have the rings marked. So going back from the outside, they have like the year 2000, then back, John F. Kennedy's shot, and then back Civil War, and then America becomes a country, and then America is discovered by Columbus, and all the way back to the birth of Christ. This tree was 2,600 years old, and they have it lying outside, and they have all these different years marked on it. It's just the craziest thing you've ever seen. Yeah, that was like one of the coolest things I've ever done. And we were so dirt poor. I got the flights for free because I had visa points, but my wife was still a student. I was teaching part-time and like working in 2 restaurants. So we went for this vacation. We hadn't been on vacation in forever. We like stayed in youth hostels and like just bummed around the city on the cheap, and it was great. It was like one of the best vacations I ever had. So San Francisco, I can say from experience, if you can get there, it's a great place to be with not a lot of money. There's tons of cool stuff to do that doesn't cost a thing, and it was really neat. We had a great time. Anyway, so if we're labeling this triangle, what label do we start with? Opposite. And how do I find that? That's right. So I go to the angle, and I go across. And that's going to be our opposite label. I do, yeah. And how do I find that? It's the longest line, or I can go to the 90 and go across from that. Yep, both work. That's my hypotenuse. And then the leftover one, what do we call that?
I'm not even going to say it.
Adjacent. Just think of the name Jason and say first. Adjacent. 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 See? Basically the same.
Then I'm going to start screwing up when I say adjust.
Probably true. Okay, so let's take a look here. This side, or if this is theta, where is the opposite here? Yeah, if this is theta, how do I find opposite?
You go across.
Across, so this one here. What should I label next? Good, and where is it? Yep.
Or you could go across from.
Yeah, I could say that's my 90. I could go across. I could also say that's the longest side. Whatever thinking works for you, that's my hypotenuse. And the side that's left over is the adjacent. What about this one? Here's theta, so where is my opposite? Yeah, across from it, down on the bottom. How do I find my hypotenuse? It's the one on top. How did you know? Those are both great answers. It's the longest side, which is true. You go across from the right angle, also true. That's our hypotenuse. And the side that remains? Good. That's not so bad, is it? Okay. Now, the reason we do this is, way back on the first page, we said, if I know how long I can change the angle by making this opposite side longer or shorter, right? If I set this one in stone, if I say, I know how long this side is, but I change the back one, just hypothetical. Just one way I can do it.
Oh, no. Okay.
Is I can make the hypotenuse a fixed length, right? I can change the angle by how long I make
Yeah, I just
the back line. Does that make sense?
Yeah.
The longer I make the back line, the bigger the angle. So one way I can define that angle is with the hypotenuse and then controlling the side of the opposite. Does that make sense? That's one way to control the angle. Set the hypotenuse at a given length and then make the opposite side longer or shorter. That's going to change the angle. We have a name for that. That's one of the things we're going to learn here. We say that this is a trig ratio. The ratio of how long the opposite is divided by how long the hypotenuse is. In other words, if we set the hypotenuse and we change the opposite, that controls the angle, and we call this ratio of the angle. We can control the angle's sign. S-I-N-E spells sine. It's a new word. You've probably never heard that word in your life. If you look at your calculator, whichever one you have in your hand, it probably has a sine button on it. Now, they're lazy, so they don't write sine. What do they write?
They probably write the O.
Okay. Take a look. You got a calculator in front of you. Can you find the sine button? We're going to use that sine button later, next week, we'll talk about it. But does anyone see it? They're lazy, they don't write sine, they just write sin. Make you feel like you're in Sunday school.
Not here.
Yeah. They're not actually trying to ask you to confess anything. It's just the way they're talking about the sine of an angle. So we can say how big an angle is by measuring its sine. And all its sine is, we measure the opposite. We get a number. We take our ruler out, we measure the opposite, we write that number down. And we divide that number by the hypotenuse. We measure how long it is. I know it's a little bit too big because there's going to be 3 of these. So that's one way we can control an angle. I'm just going to show that. If we had a hypotenuse and a short opposite, we'd get one angle. And if we had the same hypotenuse with a bigger opposite, we get a bigger angle. Does that make sense? You don't necessarily have to draw that. But as I change that opposite, I change how big the angle is. I suppose it would have helped if I'd drawn that line too. So that's one pair we could use. We could say the hypotenuse and the opposite can control that angle theta. How else could we change the angle theta? What would happen if I kept the opposite the same, or the hypotenuse the same, but I made the adjacent way longer? So now, this thing had to like lay down. What would happen to the angle? It'd change, it'd get smaller, wouldn't it? So we can also use the adjacent and the hypotenuse to say how big an angle is. And we give that a name. Cassie,
Yeah.
what do we call that one?
What's that?
Very good. So the cosine of the angle theta is how long the adjacent is divided by how long the hypotenuse is. And again, the calculator has a button that deals with cosine. They're lazy. They don't write cosine because that's long. What does it say?
COS?
Yeah, they just say cos. But again, it's just a short
Oh,
form.
I thought it'd be like cosine.
Yeah, no, just cos. They're lazy. It's like Joe for Joseph. It's just quicker to say. And then, what pair haven't we used? So we put opposite and hypotenuse together. We
Yeah,
call
we
that
draw
sine.
opposite and adjacent.
Very good. We put adjacent and hypotenuse together. We call that cosine. The last possible pair is what we call the tangent. And this is probably a word you have used before, but not like this. You've probably used it like, oh my God, here goes Orlando on another tangent. Why can't he ever just stay focused and talk about what he's supposed to be teaching?
Oh, I thought it
But
was an answer.
no, not tantrum, though I have those as well. And you're completely right. The tangent is the opposite and the adjacent. So these are the three primary trigonometric ratios. Isn't that a great word? Trigonometric ratio.
I don't like that word, it's too big.
So let's think about that word, trigonometry, trigonometric. What's that mean? Well, trig is obviously just short. It comes from the Latin for,
So what is it, just something you want to talk?
what is it? Trig, trig, trig. Trigonometry, but what shape is that referring to? A triangle, right. And then metric, what does it mean? What do we do with like a meter stick? What do we do? We measure things. So trigonometry is just a Greek-derived word for measuring triangles. That's all that word means. What's the name of this unit? Measuring triangles. What do we call it? Trigonometry, because it makes it sound smart. That's all. It's all for
Let's be real here.
But really, if you spoke Greek and Latin, all these science and math terms that sound so fancy, they all mean things like measuring triangles. Right? Like all the names of the
It
muscles.
sounds fancy, but it really
Yeah, it's just, they're just descriptive. And it would have made a lot more sense back in the days. It's like I was talking to my grandfather. My grandfather was an accountant. But he became an accountant almost by accident. He literally, one day ran into a guy, they got chatting. He said, hey, I run an accounting firm. I like you seem like a good kid, you should come work for me. And my grandfather left school, went with an accounting firm, did correspondence to become an accountant while working in the office, ended up being a very successful businessman as well for himself. But it was just kind of random chance. He got lucky. This guy and him were sitting next to each other at a deli, having a sandwich. At a table, they got chatting, he got a job became his life's vocation, very, very well for himself. But, and I never actually heard this story from him. My grandfather grew up really, really, really poor. Mother didn't have a dime to win. And he said, yeah, I was studying in university. I never knew this. He said, I was going to be a high school teacher. Oh, I had no idea. I said, well, what were you studying? He said, oh, Greek and Latin. Of course, right? And actually, they still There's 2 high schools in the region that still offer a Latin class, which is hilarious.
They
I think that's
actually?
great. Yeah, but most schools, and it's not something you see anymore, right?
No, you don't.
But it used to be. It used to be something we made kids do. That's before my time. I never studied Latin. Now, this can be kind of hard to remember, so we made up a nonsense word. It's just, this word doesn't mean anything. This is not a fancy math word. It just helps us remember these ratios, because you're going to have to use these a lot. So when I say sine, you're going to have to remember, oh, I find the sine by measuring the opposite, measuring the hypotenuse, and dividing. And when I say cosine, you're going to have to go, oh, I know what to do. I measure the adjacent, I measure the hypotenuse, and I divide them. And when I say tangent, you're going to have to know, oh, I measure the opposite side, I measure the adjacent side, and I divide them. And that's going to come really quickly to you. What's important is that you remember which one's which. How would you do that? I would have made a song up, but they didn't make a song up. They made a word. Cassie, what's the word? Nonsense word to remember these. Very good. So we made up this ridiculous word. It doesn't mean anything. So, ka, toa. Also a good name for your firstborn child, maybe your second-born child. Just saying, like, Sokotoa Dolan, got a bit of a ring to it. I could be one lovely girl or boy. I think it's very unisex. You go either way. Okay, why do we use this word? What's it tell us? Well, it tells us that sine is opposite over hypotenuse.
Oh my god, I get it.
Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Isn't that clever? So it's a word that's easy to remember, fun to name your children, and it reminds you what the 3 trigonometric ratios are. This is an honest-to-God true story. My son was born at Christmas, and my wife, who I assume must have been dipping into the eggnog, decided at one point that we should name him Wenceslas. To which I said, that's fine, but it won't be Orlando, because I'm leaving if you name my kid Wenceslas. But you know, like good King Wenceslas? Anyway. But had she said Sokotoa, I'd have been all on board. So I will actually usually write it like this, because then it really reminds me, like, Sokotoa, it reminds me, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Michael, you won't make me jealous if you name your daughter Cosine. Sparrow. No? I remember when I said that. Then I had a kid. So once you've got that written down, we're going to go to the next page and just do some calculations. We're going to do a little math. Imagine that. So I have a lovely triangle here. Now, even though it's called DEF, in this unit, we're not going to name the sides DE or FD or FE. Are other people finding that it is suddenly magically very warm in here?
Yeah, that's
I was
gone.
thinking I might turn the heat off. Is that okay with everybody? Tell me if you object, but I decided long ago that in lieu of exercise, I would just wear baggy clothing. And I find it a little warm. Okay. So, this triangle here, we're going to name the sides, which we know how to do, and then we're going to calculate the 3 trig ratios. We're going to find the sine of our angle, the cosine of our angle, and the tangent of our angle. Now, in this triangle, what angle are we interested in? 3 angles. Is this guy down here? Is this guy up here?
Interested in angle
That guy down
B.
here. Which one?
Angle B.
Good. This is our theta. And I'm going to say theta a lot. So you get used to me saying. Theta, the angle we're interested in, is this one down here. That is our angle of interest. So, let's label the sides. What side should I label first? Opposite. How do I find it? Across from theta. So here it would be this one over here? Good. So that's going to be my opposite. Good. What side do I label next? And how do I find it?
Across from the right.
Good. And is this the right? Great. So like this one up here would be the hypotenuse? Great. And what does that leave? the adjacent. Good, and that's this one down here. Good job, guys. It's not so bad, is it? And here's the nice thing. Last unit, every single question we like wrote out the ratios after like naming all the sides of the triangle. In this unit, every single question, you're going to start by figuring out what angle you're interested in, labeling hypotenuse, opposite, adjacent.
Oh, thank God.
You're going to do this a lot, and it's nice and easy. It's a straightforward skill. Now, this angle theta, I want you to measure it just in degrees. Use a protractor and tell me how big theta is in degrees. I don't know why it's easy to get 5. So just on the page, sorry, not from the page, I guess that's a lie. I just threw that at you. But I wasn't like trying to, wasn't trying to hurt you necessarily. And I want you to physically, on the paper, put the protractor down. And I think you'll probably have to do it this way, if you want to go from 0 to like a nice number. And I got what? I think I got about 12. What do you get?
I don't think I'm measuring it right.
Yeah, you got to put it so that starts at 0. I mean, you can see it's a little above 10, but you don't have to fix it. So usually what we do is and now it's down here. That makes sense? And I think, maybe 13. Yeah, so maybe 13. Is that one able to do that? Is that one struggling with protractor? So you just want to arrange your protractor so that it's measured out from another Again, I just put my protractor up. Either one's fine. So, one of the ways, look here. One of the way we can measure theta is we can say it's 14 degrees. Is that comfortable? That makes sense to everybody? And we did that just with a protractor. Protractor or protractor? I'm putting or. Okay. So one of the ways we can say how big this angle is just by measuring it with a protractor. But we can also measure this angle using our 3 new ratios. What are the 3 ratios we just learned? Well, the first one we called sine. And I'm going to get in the habit of just putting 3-letter acronym, because that's usually what we write. We usually don't write the whole word. Sine of the angle theta is equal to what over what? What's our nonsense word again? SOHCAHTOA. So tells us that sine is what over what? Good. It's the opposite over the hypotenuse. Now, let's look at our actual, how long is the opposite? .2, okay. And how long is the hypotenuse? Cassie, do you mind giving me a calculator? Would you mind giving everyone one? Thank you so much. And then we can do that on our calculator. We'll do that in a moment when Cassie's got them to you because I forgot to hand them out. But what's the next ratio?
Okay.
Yeah, we're going to do all 3. What's the other way we can measure this angle? Cosine. And what's the cosine? So, ka, like a bird. How do you say ah? What letters? A and H. So cosine is the adjacent divided by the hypotenuse. And again, look at your triangle. How long is the adjacent? 17.5. How long is the hypotenuse? 18. Great. Let's do both of these in our calculator now that we have them. I'm gonna make this all a little smaller. Sorry, there we go. I just put it all a bit too close together. Okay, we'll do better on the next two. Okay, what did we get when we divided that sign? 4.2 by 18. Like point what? 0.3-ish? No,
Yeah,
0.23? Great. What did, give me one more decimal. What did we, perfect. What did we get when we did 17.5 divided by 18? By the way, as a rule of thumb, unless I tell you otherwise, I always want 3 decimals for a cosine, a sine, or a tangent. What did we get when we did 17.5 divided by 18? 0. We'll do it. Yeah, what is that?
9.
You have a much better estimation of how well my eyes work than I do, I can assure you. Okay, and we have a third trig ratio, a third trigonometric ratio. What is the third trig ratio? Tangent. Great, so the tangent of theta can always be found by doing what? SOHCAHTOA, OA. What over what?
Adjacent and no.
OA, yeah, opposite and adjacent, good. So it's the opposite, over the adjacent. And on this triangle, how long is the opposite? 4.2. And how long is the adjacent?
17.5.
Very good. And do that in your calculator. Tell me what you get. I don't like that number. There you go. What'd you get? 0.24 what? Oh, really? So I'm going to put a 0 there just so we know. You don't need to worry about that, I guess, but whatever. I did. No. No, if there's no 0 there, you don't have to worry about it. Explain something. These are 4 ways of saying the same thing. Before today, you only knew one way to measure an angle.
So are all those answers?
They're all right, they're all true. What we're going to see in this unit is sometimes it makes sense to use one, sometimes it makes sense to use another. That's why we have 3. You never need to tell me all 4. But if I told you to make an angle that's 14 degrees, it will always look exactly like that, right? If I told you to make an angle that had a sine of 0.233, it will always look like that. It's just as distinct. If I told you to make an angle that has a cosine of 0.972, it's always going to be exactly that angle. And if I tell you to make an angle that has a tan of 0.240, it's always going to be exactly that angle. Does that kind of make sense? So, sorry. So sine, cos, tan are all different ways of explaining how big an angle is. Right now, they may kind of seem gibberishy because we use degrees and we're used to them, right? That number 14, we can picture that in our head. In all likelihood, you can't picture what a sine of 0.232 looks like. Maybe I'm wrong, but I bet I'm wrong. Because I can't. Well, I guess I can't. But you probably, if I said an angle with a cos of 0.972, a little angle like 14 degrees probably didn't jump into your head, probably didn't know. But eventually you will. When you work with these numbers enough, they start to make sense just like degrees, I promise. I promise you that the first time somebody said that this was 90 degrees to you, and you were a kid, you were probably like, I have no idea what that means. Why would they even think about that? These things are always confusing, first and when they start to make sense. The big takeaway today is you now have 4 ways to measure an angle. With a protractor, by finding its sine, by finding its cosine, and by finding its tangent. And any of those 4 ways tells you how big an angle is. If that makes sense to you just as an idea, just that you now know 4 ways to measure an angle, 3 of which just involve measuring the sides and dividing. Okay? What I want you to do for today, in the time that remains, is do that same thing we just did in triangles. Okay? So I want you to find the angle in degrees, the sine, cos, and the tan for the next 2 triangles. Take your time. Okay? Use that. I'm going to print your assignments. Did I do that already? Yeah. Okay, I'm just going to go grab the assignment I have you working on. Relax, it's not due tomorrow or anything. But it's just, you guys are here, it's not going to be there, or we can be there, good work on. I'll be right back, okay? Plug in the fees, and once you've got answers, walk around the front with the same answers. You can walk around the front with different answers. And that's fun.
I like this one. Do I do it? I'm on your.
This one in review of this.
Yes, you bet. But we have time. All right. So let's take a look at these. Can we do that? All right. Maybe we'll look at the first one together now, and then tomorrow we'll start the class off by looking at the second one. Yeah, we're gonna do. Okay, so this guy right here. If that's theta, what am I calling the side across from it? Great. That's okay. Now, if that's the opposite, what side should I do next? By the way, that's the most common mistake. And it's a good mistake, Mr. Dolan. Yeah, and which one's that? Very good. And the remaining side we always call adjacent. Good. Can I ask you one more thing? I'm so sorry. I know I'm a menace. Do you mind just stapling these for me? The two pages each.
Is it for this class?
Yeah. So now, who measured it with a protractor? What did we get? Did everyone get around that? Great. Okay, now what are the three trig ratios we need to use? Sine, yeah. Sine theta. And how do we calculate sine? I know you picked the wrong sides, but that's okay. What ratio is it? Like, what am I doing? What over what? Opposite over hypotenuse. So what is the hypotenuse? Because I bet you have that right. Hypotenuse. The one up, yeah, you're right. 14.1 up top for the opposite. And the hypotenuse is 7. Did anyone do that in a calculator? What'd you get? 844. Great. What's the next ratio? By the way, that's what you should have gotten for your cosine, I bet. If you flipped them. That's okay. What's the next ratio? Cosine. How do we find cosine? Adjacent. There you go. Like, and the Argonauts. All right, what is the adjacent? 9.0. And the hypotenuse is still 16.7. And so what do we get when we do that? You guys are good.
I can't follow both of you. One you say it.
Good. And what's our last trig ratio, the third one? Yeah, and what do we call that one? Tangent. Good. And I want to get in the habit, guys, even though we write the short forms, I want to be in the habit of saying the full forms. Tangent, cosine, and sine. Just it's good. It's a good habit of mind. And how long is the opposite? Yeah. And how long is the adjacent? And so this is going to be what, like 1.6, 1.7? 1.566? Oh, for goodness sakes, stop. And we said 0.566? 1.566, right. Yeah, because 14.1 is bigger than 9.0. Okay, there we go. That's great. Good job. And again, if you screwed that up, don't be shy. It's your first day doing this. Two more things. Sit down. Two more things. One, this evening is parent teacher night. It is so much less